Hey everyone, check this out. So what we have here, what's going on right now, is I'm taking digital video off this old camera using SDI. It's coming into the HAL and it's getting recorded onto this Dylan. This is a disc array from Quantel. You've seen one before because I tried to fix one a number of years ago and completely failed. But here we are. I'm recording this in real time, straight to this old vintage disc array through a fully working HAL. So absolutely amazing we've got to this point. The story has been quite epic. So this video is going to be all about how I ended up with my HAL, this Dylan, and how we got it working. Because yeah, as I said, the story is a bit epic. So it's probably going to be a long one, but stick around. There's going to be loads of really cool technical stuff going on. So let's get started. Hello viewers, welcome back to the lab. You've hopefully watched the update video that I made, sort of trying to detail a little bit about why I've sort of disappeared for so many months. Just want to thank all those people watching now. Thank you very much for sticking around and still following me and all that sort of stuff. Thank you very much. I also want to thank my loyal patrons. They've been amazing and have also stuck around, thankfully. Yeah, things are going to change a little bit around here in the lab about how often I make videos, just because of life gets in the way sometimes. So, but we're here now, we're making a video. It's a very significant one, so hopefully you'll all find this really interesting. But first off, this video is sponsored by PCBWay. This episode of Dex's Tech Lab is sponsored by PCBWay. PCBWay is your go-to resource to turn your electronics projects into reality. From PCB manufacturing with all the options you could possibly need. CNC machining, 3D printing, sheet metal fabrication, injection molding, you will not be short of options. I've used PCBWay myself and can personally attest to their service and quality. Go check out PCBWay.com, and I want to thank them for their support. Right, okay, we're getting started, don't worry. So hopefully you have seen the Quantel HAL restoration videos and the Quantel Dylan restoration videos that I made about 2 years ago. They came about because I bought myself a non-working Quantel HAL and a Dylan. Those machines I tried to restore. I got the HAL working to a certain extent, but it turned out there was a problem with my Dylan disc array. It was a hardware issue on the main board and I didn't really know how to fix it. So I didn't give up. I just put it on hold, put it on a back burner, packed them all the way into storage. And a few things have happened this year which have meant that it's now come out of storage. It's now here. This is my old HAL that's running, and we have this new Dylan. So the significant thing that happened at the beginning of the year was we were contacted by somebody and they had 2 Quantel HAL machines and 2 Dylan disc arrays. These were unknown to us in the past. Robert has now joined our Discord community, and one of those machines has been purchased by a friend of mine, Matthias, who lives in Cologne, and we brought those machines from Swindon, which is where they were located, up here, and I attempted restoration on the HAL and the Dylan. Restoration of the HAL went fairly smoothly, although it did turn out there was a few significant faults with the HAL which I couldn't really get over. One of them was the Quantel image card, which is one of the big video processing cards in these machines, and that had some quite serious issues with the FPGAs that are on it. They weren't programming, and I had to hold my hands up and say, I can't fix this. As I said, it also had a few other faults, so what I opted to do was use my HAL instead. So at the point where I sort of changed over and switched to using my HAL, we were actually at the point where I could connect the DL disk array to, at the time was what we call the Swindon HAL, and I was able to the DL starting to get running. Although the HAL itself wasn't really working, I could still talk to the DL and do things on it that I needed to do to try and test it out, because inside one of these you have 20 1 GB spinning hard disks, and they all need to be working in order to get a fully working DL. Now, given the age of these machines, the chances of all of those disks working were pretty slim, and yes, some of them were bad. I also had the disks from my old DL as well, so we had a total of about 38 disks. In trying to weed out the bad disks from the good, I opted mistakenly to use the built-in function in DL to format the disks. Now, back in the day, this wouldn't have been a problem, because if a disk failed format, then you would just take it out and swap it. But here and now, we didn't really have that option. So unfortunately, I continued to format the disks, and it turned out that a huge portion of them just died. During the format, they would fail partway through, and then forevermore, if you tried to access the disk, it just said media error, and you couldn't format them again. It only ever reported a media error, and that rendered that disk basically totally inoperative. So after all that had happened, I actually managed to get 9 of the 38 disks 100% formatted. So it gave us 9 disks that we knew were fully working. But that obviously wasn't enough to get the whole machine running. So we were in a bit of a quandary what to actually do. Myself and Matthias had several discussions about ways to move forward with this. One of those thoughts was, because Matthias has a working HAL and DL in Cologne, what we could possibly do is look at SCSI disk emulators like BlueSCSI and ZuluSCSI, and see if we could use those in place of the spinning disks. Now, the problem is that both of these require a significant amount of investment to go and purchase that many of those drives on the off chance that it might work. So because that was a bit of a grey area, what we did, we bought a BlueSCSI and a ZuluSCSI. I did some benchmarks on them just to get a rough idea on what sort of performance that they would be capable of, to see whether they might be compatible with the DL. You see, the problem is that the DL was really pushing hard disks at the time, and it requires a significant amount of bandwidth going to each drive. And although the original drives were capable of doing that, they were using spinning disks and didn't have the quirks that flash solution like Blue and ZuluSCSI have, because they're using flash SD cards. The problem with using flash is a lot of the time it's really fast, but then there's portions when you have to do a flash page erase, which causes delays, and those delays are actually much more than a spinning disk would be. So if you're trying to push an SD card and actually trying to write lots of random data, the performance tends to go through the floor a little bit. And the problem with DL is the video on this array can be 100% fragmented, and that is down to the granular size of what DL writes, which is one field of video. When you're playing and recording real-time video off this, the DL will assemble all those frames and fields of video in real time and then sends them to the HAL. So the performance that you need to get out of the drives is they have to reply with their data 100% of the time. It can't be oh, I'm just a bit slow on that one, you can't do it because it's real-time video. So there is no option. It either have to be 100% fast enough or it's not going to happen. So I did a load of benchmarks, and those benchmarks told me that both BlueSCSI and ZuluSCSI should be just about fast enough to do random writes, fast enough to cope with what the Dylan was going to throw at it, which meant things looked promising. Those two drives went off to Matthias in Cologne, and he tested those in his Quantel Dylan that he has working there. So what we did, we had 19 working discs in the Dylan plus one BlueSCSI, and then we switched to ZuluSCSI. The ZuluSCSI worked straight out of the box. We didn't have any issues with it. It seemed to cope absolutely fine with the with what Dylan was doing. BlueSCSI did have an issue, which we think turns out to be a bit of a known issue with BlueSCSI, but that's looking like it might be fixed. So I think both solutions will end up working in the end. But we had one working ZuluSCSI in that Dylan disk array. So we opted to buy 20 ZuluSCSIs and install them into my Dylan to see whether I could get it up and running. It was a bit of a gamble because it was a significant amount of investment. They were bought, Matthias came over to visit, and we went through and made up all the ZuluSCSIs into the trays, the caddies, and installed them into the Dylan. We then powered it up, kept our fingers crossed, and when we first booted it, all that happened was the Dylan powered up, HAL started its software, and then just two discs were asked to spin up by the Dylan, because normally all the spinning discs are normally spun down, and the Dylan will slowly bring up pairs of drives in order to spread the load of the discs spinning up and not put the power supply under too much pressure. So it asked two drives to spin up, and that's it, nothing else happened. And myself and Matthias were just looked at it and just went, oh, well, that's not a good sign. After that, resulted in weeks and weeks and weeks of investigation and work by myself, Matthias, and several people on my Discord to try and figure out what was going wrong. Now, by this point, I had put aside the Swindon HAL and switched to using mine, this one here. Now, that had been in storage for 2 years. When I was originally playing around with it, I couldn't get the Dylan to work, so the whole thing was just packed away and put into storage. I brought it out and put it up here. Now, it turns out that back 2 years ago, I made a little mistake. When I packed it away, I installed one of the cards in the wrong slot and then packed it away. I then unpacked it, put it here, tried to use it with the Dylan with the ZuluSCSIs in, and there was a problem. Now, I didn't realise that one of these cards had been put in the wrong slot. Didn't notice it for a while, but I did notice it eventually, and it did solve some of our problems, but not all of them. There is a number of small issues with using the Blue and ZuluSCSI disk emulators on the Quantel Dylan because of how Quantel used those original discs. Now, we had a good idea on how the Dylan software works because on the Discord we have the guy who originally wrote the software for it, and we have the guy who took over writing the software for it. So them two together, although their memories were somewhat faded in places, we were able to figure out a few things that would have been going on, which answered a lot of questions. First off, we found out why formatting all of those spinning discs resulted in so many of them going bad. And that was down to how Quantel programmed the firmware on the actual SCSI discs themselves, the original spinning ones. You see, normally on SCSI hard disks, they're quite intelligent, and if you're using the disk and all of a sudden there's a sector goes bad, the drive will automatically try and recover the data, and it will automatically try and reallocate a spare sector somewhere else to be in place of the one that went bad. This is a feature called bad block relocation, and it's a feature in most SCSI disks. Now, Quantel, in their wisdom, decided they didn't want to use that feature, and they permanently disabled it in all of the drives that get installed into a Dylan. The reason they did this is because they wanted to handle the bad block records and relocation themselves. I think partly because they wanted to work at a much bigger granular size. The sectors on a SCSI hard disk are only 512 bytes long, but every allocation unit you have on a Dylan is 400 kilobits long. So you didn't want these small little blocks getting relocated in various different places, because you can go and ask Dylan to get one particular field of video, and a load of disks will go off and use the original sector that was used, but then one drive will be like, oh, hang on, I need to take longer because my sector's been relocated over onto the other end of the disk. So it creates problems. So Quantel decided to do all of that stuff themselves inside Dylan. So they completely disabled the bad block relocation. Another thing that they disabled was all of the caching. They didn't want any caching issues going on, so that was disabled. And as I said before, these disks were set to only run up when they're requested to. So when you power them on, the disk doesn't actually spin. There was a few other minor little changes as well that they did. Now, the way that these things are set is through SCSI commands called mode select and mode sense. And when the Dylan was seeing these ZuluSCSIs, and it was saying, please can I have a look at your mode select pages, or sorry, mode sense pages, to check that these things had been disabled, the ZuluSCSI would say, no, you can't, because they don't exist. So then the Dylan would have a problem with that and throw a load of errors out saying, I can't read these pages, these mode select pages. Because also that the ZuluSCSIs were all spun up because they didn't implement a feature where the disk drive is in an idle state and then it runs up and then becomes ready after a period of time, 2-3 seconds, something like that. When Dylan checked to see if the disks were running, they all said, yes, we're all running instantly. So then the Dylan said to every single one, I'll need to select your mode sense pages all at the same time. And that generated such an enormous amount of flood of errors coming out of Dylan going into the HAL, which is way more than anything that would have happened back in the day, that it generated a message buffer overflow in HAL, which meant that the HAL software crashed, and then the whole thing just fell over. HAL rebooted and just did the same thing over and over again. It spewed out hundreds and hundreds of lines of errors and just went absolutely bananas. Are you all still with me? It's getting deeper, I tell you. So we were at the point where card has been put back into the right spot. We've got all the Zulus in. They're all booting up. It's crashing HAL and Dylan, and it's not working very well. So we had to modify the ZuluSCSI firmware. Now, the guy on my forum, Kiki, who was responsible for some of the software that was on the Quantel Dylans, he went off and modified the ZuluSCSI firmware to implement these mode sense pages, to basically, when Dylan asks for them, the ZuluSCSI will just reply with, it's all set, you're fine, and Dylan would go like, brilliant, and just carry on without throwing out all these errors. We also implemented the feature for emulating idle disk, as in one that's powered but not running, and responding to the spin up command, the are you ready command, and ready. So we can have one of these ZuluSCSIs be in an idle state. The Dylan can query it, say, are you ready? And it will say, no, I'm not. Dylan will say to it, please spin up. And they will go through and pretend to be spinning up for a couple of seconds, and then report themselves as ready to Dylan. So it's very much emulating the original disks that would have been in this machine, simulating them running up over a period of, it normally takes about 10 seconds or so, normally with the spinning disks, for all the disks to be told to run up. They'll run up in pairs, as I said before. So you slowly get the lights coming on and then becoming ready as all of them respond. So once that was done, all the disks would come up. It wouldn't throw any errors at us yet. And then Dylan would report to HAL that I am now ready to be used. And HAL would then do something, we're not quite sure what, but it tried to do something with the disks, and the whole thing just crashes and then spews out another pages and pages and pages of errors back at HAL, and then the whole thing falls over again and we're back into a boot loop. So that one was a bit of a mystery because we couldn't quite figure out what on earth was going on. And after a few days of head scratching, I started to come round to some thoughts that this maybe wasn't a software error, it was some kind of hardware problem with the Dylan, which was a bit worrying because if you remember my Dylan, that had a hardware fault that I couldn't fix, and this was the only option. So if this was toast, then it was curtains. I started having a look around and I did a much closer visual inspection than I did previously, and I noticed on the main circuit board there is a number of PLCC sockets which hold the custom programmed PLDs, which are all the glue logic to make this thing happen. And a lot of them were quite corroded. We think this was probably stored in a garage, so there's probably been some dampness going on. So I opted to pull out all of the PLCC chips, clean all the contacts, put them back in, and I fired it up and it worked. It turned out that was the problem. So I attempted to write some video to the disk array just to see what happens, and it wrote data. It didn't have any issues. But there were streaky lines all over the image, which meant that there was some data that was getting lost, either to or from one of the disks. I might explain the streaky lines and how they manifest themselves a bit when I show you a bit more of the hardware and what we've actually done here. But it meant that there was some data getting lost or corrupted somewhere. So on the off chance, I just replaced one of the what we call the wing cards, which is one of the 3 circuit boards in the top here. We've got the main board, a wing card on the left and a wing card on the right. I just changed one of them, and that fixed it, and that was it. We were all up and running, or so we thought. Over the coming days, I think because this thing hadn't been used in such a long time, all the little issues that were going to come out started to come out. The image card died, so that's a second image card now which has gone bye-bye. and the disk link card that also failed. Thankfully I had spares from another HAL that I've got, and I swapped those, and it's been pretty much fine ever since. I can record and play back full real-time video and do all the effects and all that sort of stuff. So it is fully working as far as I can tell. This is a massive step forward and a massive thing for me, because I've wanted a Quantel HAL for a very long time. Because of the features that HAL has, it's just been so much more what I wanted. I love the paint box, and I love Harriet, but it's HAL where you can really do some significant cool things and really be a bit more artistic. You might have seen the intro that's at the beginning of this video. That was done on a Quantel HAL. So it just sort of shows you the things that you can do with a Quantel HAL, and why I wanted one. So this marks the end point of like the beginning of this video. I just want to thank several people for getting us to this point. That is Matthias in Cologne, Kiki, Mr. Spigot, Alec, and all of the other people on the Discord who helped, because there was quite a lot who offered suggestions and ideas. So thank you so much to all of those people. It's partly all their efforts that we've got to this point, and we have a second working HAL in the world. The only other one was the one in Cologne. This is now the second one, and weirdly there is actually a third one now as well, and that's also in Cologne. That is a different story in itself, and we'll go into that one at a different point. Yeah, what I want to do now is give you a bit of a tour round what is now a working HAL and DL and disk array, and I can explain more about it in much more detail and with authority a bit better than I could before when I looked at it 2 years ago. So what I'm going to do is rearrange the camera so you can see a bit more of the detail, and I'll point out some of the things that were a problem, and you can get to see all the ZuluSCSIs that I've put in this. So give me a moment. Okay, let's have a bit of a closer look at what we have. So the HAL is on the bottom. I'm not going to go into a huge amount of detail on the HAL because that is all detailed in my original HAL restoration video. So if you want to see more about the hardware that's in the HAL, you can go and watch that video. But I do want to talk a little bit about the DL. Obviously this was the cause of all our issues a few years ago when I tried to get it working and found I had a fault on the main board. But this is a replacement one, as I said earlier. So it's made up of 3 circuit boards. You've got to have the main control board, and then these 2 down the side are called wing cards. There you go, I've just moved the cameras for a better view. So the wing cards are here. That's the main board and the second wing card. Big power supply in the middle. Now, obviously that doesn't get quite as warm as it used to because we don't have spinning discs in it anymore. So as I explained earlier, the video data comes streaming in over this huge, great big cable at the back, gets chopped up and whisked around, and a luminance and chrominance sample from that video gets split onto all of the discs. So these are not sequentially numbered. The actual hardware numbering is rather odd. So drive 0 is just here, then drive 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So you can see at the back here we've got these PLC sockets with CPLDs in, and it was these that I have had issues with corrosion and stuff like that. But I've so far cleaned these 5. if it plays up again, I will begin cleaning the other ones, but I seem to be cleaning these ones fix the problem. There's a small modification I did here. This is the, I can pop this out. This is the serial EEPROM, which stores all of the settings and the drive serial numbers. And I desoldered this off the board just so I could have it in a socket, because it allows me to take it off and read it directly. That aided me in trying to get this actually working. So let's have a quick look at one of the drives. Let's just remove the power. So here we have one of the ZuluSCSI drives. This has been put on this bracket. So these plastic runners are the ones that were supplied on the drives in the Dylan originally, and I purchased 20 of these metal mounting plates, screws, mounting hardware, little plastic standoffs to mount the drives on here. Works really, really well actually. Quite a neat solution. Every single one is numbered, and of course all the disk image is stored on a 16 gigabyte integral SD card. The drive serial numbers and all that sort of stuff, every single one is set differently. It was a little bit of a challenge to keep track and write all 20 of these. I can tell you it does take a little bit of time, especially when we were modifying the firmware. I would have to remove all of these disks, take them out, and just have a massive great big pile of 20 SD cards I had to keep track of. So that's why they have lots of stickers and reference numbers on. So that pretty much sums up what we did. There wasn't a huge amount to do electronically on here. It was more a case of the actual time to mount everything up, plug it in, and then after that it was a software issue essentially. I did have one failure, as I said, and that was one of the wing cards. I just swapped it for a spare because, as I said, my Dylan had a faulty mainboard, but the wing cards were fine, so I could just swap, and that solved the problems. So what I'm going to do, I'm going to power this on. I'm going to dim the lights so you can sort of see all the sequence of the lights coming on, because it's, I kind of like that kind of thing. And then I will switch to video capture and we'll actually have a look at HAL, and I'll give you a quick tour. So we have all the normal painting functions that we have with Paintbox Express and Bravo. So we have all the spray functions, etc, etc. So I'm not going to go into those because you've seen them before. In graphics, that hasn't changed. That's completely the same as Paintbox. In effects, it's slightly different. You can already see here I have a timeline on display here and frame numbers. These effects in here apply to the actual, or can apply to the video clip that you might be working on. The reason for the timeline on here is because all of these are keyframeable, which means if you want to create a key on a bit of video, you can do, and all of these values and settings can be set by keyframes, and that's why we have the timeline on the bottom there. So all of these effects can be keyframe timelined, so transform effects, yeah. So that's what that is. I will show you these operating in when I actually start rendering some video. Paste up is the same, apart from we now have a clip option, and that allows us to cut out a clip, which means it's not a static piece of image. So if I cut out this is just it's just a static image, whereas if I cut that out of a clip, it would be video. So animation, that is the same that you find on Paintbox. Clips is where we have access to the video timeline and other clips and reels. The way this works is, this is my clip desk, and I can have clips on here that I'm working with. This is a clip, and a clip can be made up of reel, and a number of clips together make up a reel. So you create clips by a number of mechanisms. You can either create animation, which would be in through paste up or something like that, and you would generate a sequence of animation that would generate a clip. So I can actually show you that. So let's just cut this out again, and I turn on keyframes, and we'll say we'll do 50 frames, and we'll position that there, and on frame 50 we'll move it to there, in the middle we'll move it to there and put a spin. There we go. So there we go, creating an animation. Now when I render that, that has now generated a clip. So I go down here, and here is my clip on the timeline that I've just generated. So I can play that out. So that has generated a clip. So if I put these two clips together, that's now generating a reel. So I can actually have this on the timeline. Anything here in the center of the screen is my focused clip, if you like. So you can see here, this is the intro video that I shot at the beginning of this video. So I can play that out. There's me doing my audio sync. So what we can probably do is demonstrate some of the things that we can do. Take a copy of that. Now I have to say that HAL is actually quite intelligent about how things get copied and used. I've made a copy of that, but it hasn't really, it's just pretended to. It knows that the video hasn't changed at all, so it doesn't need to use up more space on the DL to store those frames of video. It doesn't actually copy the clip. If things start to change, it will render a new clip and write it to the DL. So anyway, so what I'm going to do, I'm just going to cut a section out of this, just so we're not going to be playing around with thousands of frames of video. So let's just snip allows us to cut. Snip allows us to trim a video, so I can do snip before, and I can navigate along. Let's get ourselves, say, 250 frames. and then do snip after. So that's generated the that's the bit that we want. So these we can just throw away, and that gives us a clip of 250 frames we can play around with. So if I put that onto the timeline, and we've got an option here called set background, so that will set it as the background to paste up. So that means now I can animate things over the top of that clip. So if I change this to 250, you can see I now have an animation over video. Now this you could do on Harriet. I could record 250 frames of video into the Harriet and have them as the background clip and then animate something over the top. It's I will probably edit this down a little bit just so you don't have to wait for the rendering. So that is now finished. So if I go back to clips, I now have an old, a new O and N. So if I take if I do play out, we can actually see what was actually rendered. So that is that. If I take the new, now if I don't want to keep the old clip, I can throw it away, but I'm actually going to keep it, so because we're probably going to use it again. So now I can throw that away because I've effectively saved a copy here. So that's our clip that we've made. So what we can do now is go back into paste up. Let's delete that, and we shall have this back on the timeline. Go into paste up, and we'll do cut clip. So you can see now that this is now video on top of video, and that's the bit that HAL can do, which Harriet couldn't. So if I render that one, I will edit the rendering out for you. Back to clips, play that out. So you can see I've got now video on top of video. So what we're going to do is generate a new clip. So we'll just do something really basic. I'm just going to blur that. So I'm just going to animate this, and I'm just going to turn it into a stencil. So white keyframe, and that'll do. So what we're going to do now, that I can throw away. Oops. Bring this back. I'm going to copy that and drop it on there, and that is now a key. So you can see now that this is going to key through. So if I turn this into another clip and stencil, so you can see that that has now created a stencil that I can use. So I can actually have something, let's just load that. So that is now keying through. So hopefully this starts to give you an idea on why HAL was so effective at what it did. So that's finished, play out. So there is our finished little clip. Now hopefully you're starting to realise how these things, the video on top of video with a key is such a big thing and allowed HAL to do really, really interesting and cool effects. And it's all about layering and multiple passes over things, and being creative about how you use your stencils and things like that. And that's what allowed you to sort of create some pretty effective animations and effects on HAL back in the day. So that is a brief look at stencils and clips and stuff like that. There is there's a few other things that we can do in here. There's some options to so if I take load into clips and do cell, that cells a frame of video basically. So this bind cell allows us to do rotoscoping, things like that. So that's one single frame of video. Now what I could do, I can say I want this to be 100 frames long, and that's now 100 frames long. There is also some functions in copy. So this is copying the clip, frame and field. So what we can actually do here, we can do time stretching. So we can, oops, we can stretch time out. So we can make a clip longer. We can also shorten it, and we can do averaging functions. So you average, what that does, that will average 2 frames together. It creates sort of a blur effect. So I can actually, I'll tell you what, let's just do this over 4 frames. I won't let this render all the way through because it'll probably take a while, but if I'll let this run for a little bit just so you can sort of see the effect. Now, as I said before, this doesn't have to be done on video. This can be done on elements of graphics that you want to incorporate into your final clip. So you can see there an averaged effect. We can join clips together and things like that. These are on the, so I could join these two together so that it's one single clip, things like that. I should probably show you some of the video input. So there's 2 other ways to get clips into HAL. One is from VTR, and the other one is just a plain capture from video. So if I grab my camera, so if I go to DJ, so I've got my old camera, so what I can do, I can actually record this just by tapping down, and that's now recording. Tap again to stop. So I'll just play that out. So that's another way to get clips into. I can also do VTR, but it's not set up, so I can't actually show you that bit yet. But it allows you to jog and shuttle through the tape and set in and out points and import it in. I should also point out that HAL does have audio capability. It can record audio, but the inputs and outputs for the audio side are a bit not easy to use set up here. I might look at showing that in the future, but for the moment I normally just don't deal any audio on HAL, just to make life easier for myself. But it can record audio. I'm just trying to think of other things that we can show you. So let's have a look at some of the effects. So let's just do clear. So this is now using the clip which is in the center of my timeline. So let's just wind that to the beginning. So if I wanted to do the blur function and blur all of this video, I could do, but I can also keyframe it as well. So if I wanted frame 1 to be not blurred, and then frame 40 to be really blurred, I can do that. So let's just render. So over 40 frames, this is going to get more and more blurred. We have a keyer, so this is the same keyer that you get in Henry. So if you've got blue screen, green screen, that kind of thing, you can use this to key video. I don't really have anything set up. Let's see if I could do something quickly. Totally unplanned. So I'm just going to record this video box. I'm going to try and key to it. It's probably not really going to work, but give it a go. I'm just demonstrating these things to you really, rather than doing anything. So effects, keyer. Let's go to the beginning. Reset all and see whether we can key that. So let's alter the key, my settings, part way through. I'm not going to be able to, that's almost white there, so I suspect I probably won't be able to do that bit. But. Right, so that's now got keyframes in the keyer, so let's do this again. So back to clips. And that's my clip and the stencil, or the key I should say. So clear off all the stuff I had here before. So you can see now it's keyed through, so I can now have something underneath that. So that's the keyer. We've got colour correction. I won't actually show you this because it's a similar concept. I can change the brightness, contrast, gamma, all these settings, and I can keyframe them and then render out a new video. Blur, you've seen that one already. Transform effects. This is available on the Harriet, but it's not keyframeable on the Harriet, but it is on HAL, so I can change these parameters as the clip runs through. There's other functions we've got. These are just filters, they're not really that interesting. So I think we've probably covered a lot of this. There is also another function that HAL can do, which is ALF or ALF, which is video tracking. So I can do a 1, 2, 3 or 4 point track and then transfer that track into paste up and actually have things animate using that tracked information. So you can a very common use for this was to replace a number plate on a car in an advert, for example. So you track the 4 points of the number plate and then you can paste over the top the number plate that you actually wanted and create a new video. I will probably show you things like that in a bit more detail in separate videos. Right, before I go, I'll just show you a little video of what HAL and Dylan look like when it's recording video, because there's quite a bit going on. So if I do record, so as you can see, we've got the Dylan and we've got the status lights and on the front. So if I actually hit record, I can actually record and record the recording. See what I mean? So that is literally now recording this video. HAL's not really doing anything because it's just literally just passing the video through, but you can see those ZuluSCSIs getting hammered. And we can play through that. So as time goes on, I'm going to learn more about HAL and how I need to use it, because I do want to start creating more and do less fixing, hopefully. As I said before, the HAL is a very, very capable machine, and I'm really, really interested to learn about how to use it properly. Thankfully, we've got a number of really good HAL artists on the Discord, and hopefully they're going to give me a bit of a hand and some lessons on how to actually make interesting things on this. So as I learn more about it, I'll probably make other little video features on certain things that I've learnt about, and I can demonstrate. I'm going to end the video here because there is going to be more videos coming very soon. There's definitely been some updates since I got this running. They're quite significant. So I want to explain things that we've been doing to HAL since I've got it running. So stick around, there's going to be more videos to come. Thank you to my loyal patrons and my Discord and all that good stuff. Thank you very much, and I will see you on the next video. Bye for now.